Because there are going to be some problems we need a calculator for. These were two of them, but we'll run into some others in the notes that we need a calculator for. So I hope you subtracted 6 and divided by 3. Is that what you got? Or divided by 5, I mean. Is that okay with everybody? Now, what's different about this? Yesterday when we did that kind of equation, what did we end up with here? Root 3 over 2, or 1/2, or one of our numbers off our unit circle, right? This one is not an angle that you know. So you're going to need your calculator to help you find it. Okay? Now, to find the angle whose sine is -3/5, isn't this another way of writing that? Find the angle whose sine is -3/5. So let's go ahead and type that in on our calculator. Second sine -3/5. And did you get -0.644? Actually, I'm going to keep it and just say 6435. Did you get that? Okay. Now, this is where we have to be smarter than the calculator. Look at the directions. The directions are find all of the angles all the way around the circle. So if we look at our whole circle, would you agree that the answers I'm looking for are somewhere here and here? Because that's where sine is negative. Now the calculator told me that this angle right here is -0.6435. Would that mean that this angle right here, this shaded part right here, is also 0.6435 in terms of a number, size? Now let's answer the question, because neither that nor that are the answers to the question. We need to be between 0 and 2 pi, so we have to be positive. So what's your idea? We need this angle right here. How will I find the measure of that angle? Guys, okay, let's pretend it was a pi over 6 angle in quadrant 3. Let's pretend that was a pi over 6 in quadrant 3. How do you find the actual angle? It's not pi over 6, it is 7 pi over 6? Because don't you have to go halfway around and another pi over 6? So 1 and a 6th? So how am I going to find this angle right here? Pi plus, and I'm using my pi button, 0.6435. So that red angle is 3.785. Now what's the other answer to the problem? Well, again, it has to be positive. So I'm going to go all the way around to here. That would be like, in this example, 11 pi over 6. How am I going to find that green angle? You guys, someone tell me. Exactly, Anna, thank you. So 2 pi minus 0.6435. So 5.6, well, if I go to 1,000, 5.640. So I still get 2 answers. I get one from quadrant 1, or quadrant 3, and one from quadrant 4. but I have to manipulate the answer that my calculator gives me. The calculator gave me what we call the reference angle, 0.6435. But then I had to put that 6435 in the right quadrants and positive. All right, let's try this one. What's this one going to say? Cosine x equals 5/6. Now, 5/6 is not one of your unit circle numbers, but I do know that the angle would be where? Where would it be if the cosine is 5/6? Either in quadrant 1 or quadrant 4. Would you agree with that? So how will I find my reference angle? How will I find that? What will I type in on my calculator? Arc cosine, or second cosine, 5/6. Okay, remember, I'm looking for an angle whose cosine is 5/6. That's what this says. Find the angle whose cosine is 5/6. So, what does my calculator say? Second cosine 5/6, 0.5857. Now that means this is also 0.5857, right? Not the angle itself, but the measure of that right there would be the same as the measure of this, agreed? So what are the two answers to the problem? What's the quadrant 1 answer? 0.5857, yep, exactly, just right there. How will I get my quadrant 4 answer, which I have to go all the way around to that point? How will I get that? 2 pi minus, that's exactly right. So 5.6975. Okay, now let me give you one more to try on your own. A simple little equation, but calculator required, which means you have to do a little extra work. So how about 5 tan x plus 11 equals 4. Let's see if you can solve that between 0 and 2 pi. So Xander, is your pencil moving?
Yeah, it's.
Okay. Well, you can get it started.
Yeah.
Yeah. What do I know about tangent? Tangent has to be what?
Oh, it's gonna be y.
Okay, time out.
I would
Solve this
start with
equation.
minus the 11,
Mm-hmm.
and then divide the 5.
Yep, so negative 7/5.
Yeah.
Now, what does it tell you if the tangent's negative? Where am I?
Bottom right, fourth quadrant.
Fourth quadrant,
Fourth.
4. I'm going all the way around the circle. Second. So my answers are going to be this red angle and this blue angle. In order to find those, I have to have a starting angle. So how do I find my starting angle? What do I type into my calculator? Second tangent, negative 7/5, negative 0.9505. Remember, you have to round to at least 1,000. You have to round to at least 1,000. Everything you do. Okay, did you get that? Everybody there? Is negative 0.9505 an answer? No. Because your answer has to be positive. However, if that's 0.9505, isn't this right here also 0.9505? So how will I get my answer? How will I get the red answer? Pi minus 0.9505. So the red answer is 2.191. Did you get that? Somebody? All right, now I need the blue one. Where's the blue one coming from? Well, blue is all the way around to here. So that's going to be 2 pi minus that. .333. Okay, you all right with that in case we run into a problem where we need to use our calculator? All right. So a little warm up for you here. We'll solve some. Now these will not require a calculator. So these we should be able to do the same thing without a calculator. Which means he has carefully examined everything. Okay, here we go. What are you doing with that first problem? Oh, I erased my directions, but it's the same, 0 to 2 pi. What are you doing here? How are you going to start this problem? Divide by negative 2. Thank you so much for participating. All right. Now, I see a root 2 over 2 cosine. That clues me in that it's what kind of angle? Pi over 4. But it's a negative cosine, so it would be a pi over 4 here and here. So what's the answer? 3 pi over 4 and 5 pi over 4. Kids, you just did exactly what we did on the calculator, only this was easier because the numbers you're more comfortable with. You took pi minus pi over 4 and pi plus pi over 4. That's what you did. Perfect. All right, try number 2. I'll do it up here. Try not to look. Look if you get stuck. Well, let's see if you can do number 2. Subtract 5 and divide by negative 4. In other words, get your sign by itself. You get positive 1/2. Sign is positive up here. What is the angle that has a y value of 1/2? Pi over 6. So pi over 6 in quadrant 1, pi over 6 in quadrant 2. Raise your hand if you got that right. Good. All right. Do I have volunteers 3 and 4, they are the same kind of problem. I have a volunteer. Thank you, Xander. And Rena, perfect, wonderful. Here's a- I thought you were coming up.
Yeah, I was.
Get up here, we don't have time to wait on you. Oh wait, never mind, Anna's got it.
Yeah, that's what I got.
I'll show you work. Whatever work you need, you don't need to show every single step maybe, but.
Yeah.
Wow, they did that fast. What do you think about their answers?
Yeah, that's
Emily's
fine.
nodding back there. Everything looks good. This one only has one answer because there's only one place where y is -1. Okay? All right, number 5, worded differently, done exactly the same way. If we are looking for their points of intersection, don't we just want to set our equations equal to each other? All right, go ahead, solve 5, 6, and 7. Let's solve 5, 6, and 7 and see what you get. I do not know if these are the right answers, I'm just walking around looking at people's papers and taking them down, so don't write them down, I don't know if they're wrong.
Wait, that's so true. Wait, so then you divide both sides by -2?
Yeah, we did, yeah.
Okay, so then sine x is root 2 over 2?
Yeah.
subtract. Just did add, subtract, plus.
Okay, guys, on a problem like number 2, these are like x's. You want to get them combined like terms. So we're going to subtract 5 sine x from both sides, and we get 2 sine x. Just like you do with regular variables. Sine x is your variable now, but if you have 7 of them and you subtract 5 of them, you're going to have 2 of them. Okay? So for this one, this is problem 6. Sine x equals negative root 2 over 2. And I copied off somebody's paper, and they said 5 pi over 4 and 7 pi over 4. I think they're right, because that's a pi over 4 angle in quadrants 3 and 4. Perfect. So 7 is the same thing. If you are combining your tangents, you're going to add this over. That's going to give you 7 tangents. X doesn't change. We have 5 apples and we add 2 apples. We have 7 apples. And then subtract 3, I get 0. So where does the tangent equal 0? Tangent is y over x. Where is y over x? 0. Drew's going like this. Yeah, this is where y over x is 0. So what are my answers? 0 and pi. If you had trouble getting those equations solved, are you okay? I mean, does that make sense to you? You treat them just like x's. And then, I don't know, I didn't check this one. This one was a little easier. Did you get pi over 3 and 5 pi over 3 for the first one? Nodding. Anybody not? You okay? All right. I found another worksheet. I can save that. Actually, I think I'm going to give you this. We're going to do a couple more, and then we're going to start seeing quality. Don't lose that exercise we just looked at, because it has a backside. that you may have to put on. Alright, let's look at a couple of these little harder ones. Let's start on this worksheet. Let's start with number 6. We did a couple of these yesterday. I want to make sure everybody's on board before we add the inequality element. Just to make it a little bit more interesting. Okay, what are the zeros? Zeros happen when the function equals 0. That's what it means to be a 0. It means you equal 0. Alright, so here we go. We're going to solve this guy. So what shall we do first, Ellen?
Maybe 3. Yeah, subtract 2.
Subtract 2. Thank you, phone a friend. Then what? Divide by -4. And then what? Square root. And when we square root, we have to remember it's plus or minus. That number may not look familiar to you, but it's the same as root 2 over 2. That one looks familiar. What kind of an angle are we talking about if the cosine is root 2 over 2? Pi over 4? Now what does the plus or minus mean? It could be in any quadrant. So what are my answers? If I have a pi over 4, Quinn, what are you doing, my friend? Hang with us, okay? If I have a pi over 4 in any quadrant, what are they? Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Got it. Now let's look at number 7. Cosine squared equals cosine plus 2. What do you think? Get everything on one side, because what kind of an equation is this? Quadratic? And if I'm going to solve a quadratic equation, I need to have a set equal to 0, so I can either factor it or use the quadratic formula, right? So here we go. What am I going to do with this guy? Remember, your variable is cosine theta. So isn't this the same as x squared minus x minus 2? And if you were walking down the hallway with any other kid in this school, because you learned this when you were a freshman, what would you do if you found that? You'd factor it. And you would factor it how? Minus 2 plus 1? Well, okay, that's great. That would mean x equals 2 or x equals negative 1. But keep in mind, our variable wasn't x. What was our variable? Cosine theta? So cosine theta equals 2, or cosine theta equals negative 1. You do not have to do the problem in terms of x. Some of you will go straight from here, you'll just factor that and say cosine minus 2 plus 1. You'll just do that. But if you get stumped, think of it in terms of a baby equation. Solve it, and then put your correct variable back in. All right, so here we go. Cosine equals 2. Where does that happen? It doesn't happen, because what do we know about sines and cosines? How high do they go? 1. Sines and cosines can't be bigger than 1. Go all the way back to SOHCAHTOA. Opposite over hypotenuse. Can that be bigger than 1? No. So this is kind of extraneous. There's no solutions that come out of that. None. Can the cosine be negative 1? Yep. One place. Where does that happen? Pi. So we did all that work and we came up with one measly answer. Pi. All right, let's take a look at number 8. Now, if you word the questions in lots of different ways, what are the x coordinates of the points of intersection? Doesn't that mean we want to know where they're equal? So we just set our two functions equal to each other. How would you suggest we solve this? Get them on the same side? I heard somebody say it. Get them on the same side. So 4 cosine cubed minus 3 cosine. Take out a cosine. So again, we're factoring, not the same kind of factoring we did over there, but we're factoring out a GCF. So take out a cosine, and what will we be left with? 4 cosine squared minus 3. Now we'll set them both equal to 0. So cosine equals 0. Or 4 cosine squared minus 3 equals 0. Oh yeah.
Subtract that 3.
Subtract that 3. Divide by the 4.
4, well, it's squared. Yeah, wait. Root.
Take the square root of both sides. And miracle of miracles, what do we get? Root 3 over 2. So cosine x equals plus or minus, don't forget, plus or minus when you take the square root. You okay? So what are the answers? You're not done. What's x? If the cosine is 0, then x is pi over 2 or 3 pi over 2? Okay, so there's 2 answers already. Where is the cosine plus or minus root 3 over 2? Well, it's in every quadrant. And how big is the angle? Pi over 6. So we'll have pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So this problem had 6 different answers to it. All right, number 9. What are the x coordinates of the points of intersection? So what do we do? How do we start? Make them equal to each other. So tan squared equals negative tan. And then what? Oh, just talk to me, please. What?
Add it.
Add tangent. Okay,
Let's factor it.
factor it so we can take out a tangent. And if we pull out a tangent, GCF, what are we left with? Tan plus 1.
Just set it both equal.
So tangent equals 0, or tangent equals negative 1. Where does the tangent equal 0? Tangent. 0 and pi, very good. So I don't know what you're thinking, maybe you haven't memorized, I don't know. But you wanna be visualizing your unit circle, and you wanna be thinking about your quadrantal angles, y over x tangent, where is that? 0. Where is the tangent? -1. That is a pi over 4, here or here, because it's negative. So that would be, what did you say, 2 pi over 4, and 7 pi over 4. Okay? Now, we might as well bring back a blast from the past. Go ahead, look at the next page. Another one of these. There's something about the way some of the free responses are described that makes me think something like this might be there. So we're gonna know it, whether it's there or not, we're gonna know it. So all right, take a second. We've got 9 minutes, we have to have this done. So take a second, read the problem, chat with your neighbor, and see if you can come up with the points.
No, they were like no. I changed them. I can't see it. Because so if it's when it's in the center, it's a distance of 45, right? And I said when it's at its highest, it's at 50. So that means the difference between the center and the highest, like the top and bottom is 5, right? Because 50 minus 45 when it's in the center. So I just subtracted another 5.
Decreasing and decreasing.
I got that.
Patrick, what'd you come up with? You got some points?
Yeah.
Okay, let's talk about yours. Maybe they're right, maybe they're not. Let's talk about it. What'd you get for F?
0.50.
And that meant P would have to be
450.
450. Okay. And J is 2 something. Do you know what do you have for J?
40.
And then G was 1.
145. K was 345.
All right. I just randomly called on Patrick because he was off task and asked him to give me these numbers, and this is what he gave me. I don't know, right or wrong. What do you think? Anybody agree with Patrick, first of all? Oh, Patrick, a lot of agreement. So tell me how you arrived at these numbers.
Well, it said the table was 36 above the ground. In the center of the crank was 9 inches above that, so 36 plus 9 was 45, which is your midline. And it said the distance between point B and the level ground is 50 inches, so I did 50 minus 45, and so so plus 5 and minus 5, like
The
50 to
radius for
40.
the crank.
Yeah, the radius, yeah. And then I just saw that it was 4 seconds, so just did that.
Beautiful, beautiful, beautiful. I hope you listened to what he had to say because his logic is impeccable. For review, let's write the equation of this curve. Okay? Doesn't ask us to, does it? No, but let's do it anyway. Let's write the equation of this curve. Since that's 0, should we just start right there? And if we start there, then this is a cosine curve, and it would have no phase shift, and its amplitude is 5, so it's 5 cosine something x, and then plus 45. Now, we need this number, which we've been calling b, and we know that 2 pi divided by b is the period. And what's our period? 4. So 2 pi equals 4b, and it looks like b is pi over 2. Bless you. Is that okay with everybody? All right, quickly. From point G to point J, G to J, what are we doing? It's positive and decreasing. It's going down. The rate of change, however, is negative. It's going down, so the slope is negative, but it is increasing because it is concave up on that end. Perfect. All right. Well, we didn't get as far as I hoped, but we got to. Tomorrow, I guess Monday, we will